Alright, I wanted to post a solution for question 47 because the answer in the back of the book does not match up with this question. It says that while only 5% of babies have learned to walk by the age of 10 months, 75% are walking by 13 months of age. If the age at which babies develop the ability to walk can be described by a normal model, they want us to find the parameters. So we have a normal model here. And it says only 5% of babies have learned to walk by the age of 10 months. This 10 months tells us the units that are going to be on our horizontal axis. So we have months. So it says 5% have learned by 10 months. So we know we have the mean here. We don't know what the mean is yet, but we know that it's right here on the normal curve. We say, okay, well, if we try to put 10 months to the right of the mean, then that means we would have 9 months, 8 months in the direction off to the left. So there's no way, if we have 10 months here, that we could represent 5% of the babies having learned by this time or before. It doesn't work, so it has to be on the other side. So the 10 months would have to be here, and the 5% would be here. So this is representing 5% of the babies have learned to walk by 10 months or before. Okay, then it says, but 75% of them are walking by 13 months of age. So kind of in the same token, we couldn't put 13 to the left of the mean and have 75% of the babies walking by 13 months or before. So that 75% has to be here, so then the 13 would be here. And now we have 75% of the babies have learned to walk by 13 months or before. We still have 25% of the babies that are yet to learn. They'll learn in month 14, 15, etc. So we have 75% here. And so they want us to find the mean and the standard deviation. So we have two unknowns. I'd say that probably the easiest way to do this is to take the 5% and the 75% and convert those to z-scores and put those corresponding z-scores in these positions on the normal curve. So we're going to do that. We're going to do second distribution, inverse norm, which is 3. We have 0.05. So we have approximately negative 1.64. So approximately negative 1.64. And then we're going to do the same thing for 75. So 0.75. And we get a z-score of approximately 0.67. Positive to the right, negative to the left, so that makes sense. So then what we have from here to here, what we have is 1.64 plus 0.67. We have 2.31 standard deviations between these two values. Okay, it's like finding the distance. You just take the highest minus the smallest minus the negative becomes plus. This 2.31 standard deviations also represents 3 months. So what we can say is 2.31 standard deviations, which is sigma, and we can we'll just use S, has to equal 3 months, not 30. 3 months. So to find the standard deviation, all we would do is divide by 2.31. And when we do, S is approximately 1.3 months. So that gives us our standard deviation. Now we need our mean. The fact that we only have one unknown, we could go to our z-score formula if we wanted. Using either one of these, we should be able to find the same mean. We could say negative 1.64 is equal to 10 minus the mean divided by the standard deviation. So when we take the negative 1.64, we multiply by the 1.3, we subtract the 10, and divide through or multiply through by a negative. We get the mean to be approximately 12.132 months. And maybe it's 312. 132 months. So we have our mean and we have our standard deviation. Another way you might want to look at standard deviation, 13 is approximately 2/3 of a standard deviation above the mean. Given that our standard deviation is 1.3 months, if we take 0.67 times 1.3, That 2/3 of a standard deviation converts to approximately 0.871 months. So if we come back here and we say, okay, 13 minus 0.871, because we're saying we're 2/3 of a standard deviation above the mean, so to get to the mean we want to subtract this value. We get approximately 13 minus the 0.871. We get approximately 12.129. The only reason these are slightly different is because of a rounding error. So that's another way of doing it. Now, if you wanted to use systems, which some people have chosen to do because they said, okay, well, we had two unknowns, so we need two equations. They used the z-scores and the z-score formula. Let's see, 10 minus the mean as we did here, divided by, assuming we don't know the standard deviation yet. It's another way of doing this problem. And then we have 0.67 is equal to 13 minus the mean over the standard deviation. We can cross multiply, and we get negative 1.64 times the standard deviation equals 10 minus the mean, and 0.67 standard deviation equals 13 minus the mean. Using elimination, I'm going to multiply through by a negative, so then when I add these two equations, the mean variable cancels out. So then what we end up with when we add this is we end up with 2.31 or negative 2.31 standard deviations, as we did before, equals a negative 3. And so just as we did here in this equation, we take the negative 3 divided by a negative 2.31, and we get a standard deviation of approximately 1.3 again. From there, just like we did above, you can just plug that into either one of these, and you're going to get your mean to be approximately 12.132. And that's how you solve question 47. 49 is similar to it. You just have to make sure on part D, when it says that 12% weigh over 70 grams, that you use 88% for your z-score and not 12, because it's going to be to the right of the mean. And that's hopefully going to be helpful to you. If you have any other questions, send me an email and I'll try to post a video, or you can catch me early in the morning.